Welcome back. Let's practice evaluating variable expressions. All right, so here's our first example. We want to evaluate x plus y when x equals 7 and y equals negative 2. Okay, so when you want to evaluate a variable expression and you're given some values that each variable is equal to, what you want to do is simply replace each of the variables in the variable expression with what they are equal to. You want to substitute in, or as I like to say, you want to plug it in and then do the math and simplify to get a final answer. All right, so in this case, we have x equals 7 and y equals negative 2. So we want to substitute in or plug in 7 for x and negative 2 for y. All right, so doing that will give us 7 plus negative 2. Okay, one more time, I plugged in 7 for x and negative 2 for y. So now all there's left to do is simplify our expression, and 7 plus negative 2 is equal to positive 5. That is the value of this variable expression, x plus y, when x equals 7 and y equals negative 2. Let's take a look at another example. Here we want to evaluate this variable expression, 6x minus 2y plus 3z, when x equals 2, y equals negative 1, and z equals 3. All right, so this time we have 3 variables, and each of them appears once within this variable expression. So just like with the previous example, all we want to do here is replace each of these variables with what we are told they are equal to. All right, so we know x equals 2, we know y equals negative 1, and z equals 3. So let's plug those values in for x, y, and z in this expression. We have 6 times x, so if x is 2, that means that we will have 6 times 2, and then we are subtracting 2 times y, and y is equal to negative 1, so we have 2 times negative 1, and then we are adding 3 multiplied by z, and z is equal to 3, so we have 3 times 3. All right, and so then doing the math here, make sure to remember your order of operations. We want to do all the multiplication first before we do any addition or subtraction. So let's multiply all these values together. 6 times 2 is 12, so this is equal to 12 minus 2 times negative 1, which is negative 2, so we're subtracting negative 2. And then we have plus 3 times 3, which is 9, so we have plus 9. Then simplifying further, we have 12 minus negative 2. Remember that subtracting a negative number is the same as adding the positive version of that number. In other words, those negatives cancel each other out, and we'll have 12 plus 2 plus 9. And 12 plus 2 is 14, so this is equal to 14 plus 9, and 14 plus 9 is equal to 23. All right, so 23 is the value of this variable expression when x equals 2, y equals negative 1, and z equals 3. Let's take a look at another example. Next up, we want to evaluate this variable expression, a divided by 2 plus b divided by 3 plus c divided by 4, when a equals 4, b equals negative 3, and c equals 12. Okay, so once again, to evaluate this variable expression, we want to replace a, b, and c, the variables in this case, we want to replace them with what we are told they are equal to. And so in this case, a is equal to 4, b is equal to negative 3, and c is equal to 12. So we want to substitute in or plug in 4 for a, negative 3 for b, and 12 for c. So here's what that will look like. We have a divided by 2, so that will be 4 divided by 2. So I'll write that down, 4 divided by 2, plus b divided by 3, and b is equal to negative 3, so we have negative 3 divided by 3, and then plus c divided by 4, and c is 12. So we have 12 divided by 4. And then we want to simplify, and remember your order of operations. We want to do all of our division first, and then we'll add our terms together. 4 divided by 2 is 2, so this is equal to 2 plus negative 3 divided by 3, which is negative 1. And then we have plus 12 divided by 4, which is 3. So we have plus 3. Then simplifying, 2 plus negative 1 is the same as 2 minus 1, which is 1. So this is equal to 1 plus 3, which is equal to 4. 4 is the value of this variable expression when a equals 4, b equals negative 3, and c equals 12. For our next example, we want to evaluate 2 times a times b times c times d. Specifically, we want to evaluate it when a equals 1, b equals -2, c equals 3, and d equals -4. And so what we want to do here is replace each of these variables in this expression with what they're equal to. We want to plug those values in. So we're going to replace a with 1. We will replace b with -2, c with 3, and d with -4. So what we will have here is 2 multiplied by a, so we have times 1, and that will be multiplied by b, which is -2, so we're multiplying by -2. Then we multiply by c, which is +3, so multiply by 3. And then finally, you want to multiply by d, which is -4. So we're multiplying by -4. And so now we just have to simplify. You don't have to worry too much about order of operations here because all of the operations are multiplication. So this one should be fairly straightforward. Let's just do one multiplication at a time. We have 2 times 1, which is 2. So this is equal to 2 times -2 times 3 times -4. Then we have 2 times -2, which is -4. So this is equal to -4 times 3 times -4. Then we have -4 times 3, which is -12. So this is equal to -12 times -4. And -12 times -4 will be +48, right? Two negatives when multiplied together are canceled out. So a negative number times a negative number will give you a positive number, and 12 times 4 is 48. So this is equal to +48. All right, that is the value of this variable expression given these values of those variables. Next up, we want to evaluate x squared minus 5 times x times y when x equals 5 and when y equals 2. And so we want to replace all x's in this expression with 5 and all y's with 2. All right, so x equals 5 and y equals 2. Let's start with x. We have x squared. So we want to replace x with 5, which means we will be squaring 5. So we have 5 squared minus 5 times x, which is still 5. So we're multiplying by 5, and then you want to multiply by y. So you want to replace y with what it's equal to, which is 2. So we're going to be multiplying that by 2. All right, and then doing the math here, remember your order of operations. We do have an exponent here, so we want to do that first. And by the way, in case you don't remember, an acronym to help you remember the order of operations is PEMDAS. P is for parentheses, so you want to do any operations inside of a set of parentheses first. Then you want to do any exponents, then multiplication and division, and then addition and subtraction. Okay, that's going to come into play with these more complicated variable expressions that you are starting to see in these examples. So just be aware of that. In this case, we do want to do this exponent first. 5 squared is equal to 25. So this is equal to 25 minus 5 times 5 times 2. And 5 times 5 is also 25. So we have 25 times 2. And then we want to do this multiplication before we do any subtraction, because you want to do multiplication and division before addition and subtraction. And so 25 times 2 is 50, which means that we have 25 minus 50, which is equal to -25. All right, so that would be the value of this variable expression when x equals 5 and y equals 2. Hey there, real quick, before we take a look at the next example, if you find my tutorial videos here at JK Math to be helpful, then I'd like to invite you to join my membership site, JK Math Plus, where you get access to many perks, including bonus content and my exclusive community. The bonus content includes dark mode versions of my videos, extra example problems, and more, while the community is a private space online where you can post questions, have discussions, and study together with me and other members. To learn how to join and see a full list of everything you get access to as a member, you can head over to jkmathematics.com/plus. I'll have a link for that in the description of this video. So if you are interested in becoming a member, feel free to check that out. It's a great way to support me and the tutorials I make, as well as a great way for you to learn math better. But for now, let's take a look at the next example. For our next example, we want to evaluate this variable expression when y equals 3. and our variable expression is y cubed, or y to the power of 3, minus 2 times y squared plus 4 times y plus 1. All right, so there's only one variable here, but we are going to replace all of them with 3. Each of these y's we will replace with 3. We will substitute that 3 in, or we will plug that 3 in, and then simplify the expression using order of operations. All right, so we've been given y equals 3, so let's plug that in for all of the y's in that variable expression, and we will get 3 cubed minus 2 times 3 squared plus 4 times 3 plus 1. Okay, so once again, we just replaced each of these y's with 3 since that is what it's equal to. Now simplifying, 3 cubed is the same as multiplying 3 by itself 3 times. So this would be equal to 3 times 3 times 3, and then you would be subtracting 2 times 3 squared. Remember your order of operations. Do the exponent first. So you're still going to have 2, but that will be multiplied by 3 squared, which is 9. So we're multiplying by 9, and then you want to add that to 4 times 3, which is 12, and then you still have that plus 1 on the end. Okay, and then 3 times 3 is 9, so we have 9 times 3, which is 27. All right, so I'm just going to rewrite that as 27. That is what 3 cubed would be, and then we are subtracting 2 times 9, which is 18, and then we are adding 12 plus 1, which we could just rewrite as 13, right? 12 plus 1 is 13. Now, we have 27 minus 18, which is equal to 9, so this is equal to 9 plus 13, which is equal to 22. 22 is the value of this variable expression when y equals 3. Let's move on to another example. Here we want to evaluate another variable expression. We have the quantity b minus a squared plus another quantity of b plus a squared, and we want to evaluate it when a equals 1 and b equals negative 5. All right, so we're going to replace every a with 1 and every b with negative 5. So let's do that here. We will have b, which is negative 5, minus a, which is 1, and that quantity will be squared, and then we will add it to b, which is negative 5, plus a, which is 1, and square that. All right, so once again, I just replaced a with 1 because that's what it's equal to, and I replaced b with negative 5 because that's what that is equal to. And so now we want to simplify this. We want to do the math and remember your order of operations. You want to start by doing any operations inside parentheses like we have here. So we want to do this operation and this operation before we do anything else. So we have negative 5 minus 1, that's negative 6. So this is equal to negative 6 squared plus negative 5 plus 1 squared. Negative 5 plus 1 is negative 4. So we have negative 4 squared. And then finally, we want to square both of those values before adding them together. All right, now negative 6 squared is positive 36. So this is equal to 36 plus negative 4 squared, which is positive 16. And 36 plus 16 is equal to 52. So 52 is the value of this variable expression when a equals 1 and b equals negative 5. Next up, we want to evaluate this variable expression, 2x plus y divided by negative z, when x equals 7, y equals negative 4, and z equals negative 10. All right, so we have 3 variables here whose values are known, and we're going to be plugging those in or substituting them in for x, y, and z in this expression. All right, so once again, x equals 7, y equals negative 4, and z equals negative 10, so we want to replace those variables with those values. And so what we will have here is 2 times x, which is 7. So we're multiplying 2 by 7, and then we're adding y, and y is equal to negative 4. So we are adding negative 4. That is what is in the top of the fraction here, or in the numerator. That's what we call the top part of a fraction. But then in the bottom of the fraction, or the denominator, we have negative z. So we'll have negative, or negative 1, multiplied by negative 10. That's what z is equal to. So we have negative 10. All right, now simplifying, we want to reduce the top and bottom of the fraction as far as we can before we do any dividing. So let's start with the top here. 2 times 7 is 14. So this is equal to 14 plus -4, but adding a negative number is the same as just subtracting the positive version. So 14 plus -4 is the same as 14 minus 4, and that will be divided by -10. Those two negatives cancel out and give us +10. All right, now 14 minus 4 is 10, so this is equal to 10 divided by 10, and anything divided by itself is equal to 1. So 1 is the value of this variable expression when it's evaluated at x equals 7, y equals -4, and z equals -10. Let's take a look at one more example for this video. For our last example, we want to evaluate this variable expression, x squared plus x times y minus 8 divided by x times y times z, when x equals 2, y equals 1/2, and z equals -9. Okay, so this final example is really going to test your skills of evaluating variable expressions. This is by far the most complicated variable expression that we have looked at in this video. But despite its complexity, or even though it might look hard, the process remains the same. We're still going to replace each of these variables with what they are equal to. We will replace all of the x's with 2, all of the y's with 1/2, and all of the z's with -9. All right, so starting with the top part of the fraction, or the numerator, we have x squared, so we're going to have 2 squared. We want to replace that x with 2, so 2 squared plus x times y. X is 2, y is 1/2, so we have 2 multiplied by 1/2, and then we are subtracting 8, and that will be divided by x times y times z. And so we're just going to be multiplying these three values together, x, y, and z. So we have 2, 1/2, and -9. Okay, so now we've replaced all the variables with what they're equal to, or what we are told that they're equal to, and now we just want to simplify our answer here. Starting with the top of the fraction, 2 squared is 4, so this is equal to 4 plus 2 times 1/2, and 1/2 of 2 is just 1, right? So we have 4 plus 1 minus 8, and that will be divided by 2 times 1/2 times -9. Now, once again, 2 times 1/2 is just 1, so we have 1 times -9, and anything times 1 is just itself. So what we get here is a fraction with a denominator of -9, but then in the top, or the numerator, we have 4 plus 1, which is 5, minus 8, which is -3. Okay? And now we have -3 divided by -9. Those negatives will cancel out. When you have a negative number divided by another negative number, the negatives cancel out and give you a positive result. So this is equal to 3/9, but we can actually simplify this further because we can reduce this fraction by noticing that both 3 and 9 have a common factor of 3. They can both be divided by 3, and so if you reduce the fraction, you get 1/3. All right, 3 divided by 3 is 1. 9 divided by 3 is 3. And now our answer is fully simplified. We have a reduced fraction here of 1/3. That is the value of this variable expression when x equals 2, y equals 1/2, and z equals -9. Okay, and so with that, this was the last example for this video. But if you do want to get some more practice evaluating variable expressions, I do have a couple more examples available exclusively on my membership site. So if that's something that interests you, feel free to look into becoming a member. You can find all the details on my website at jkmathematics.com/plus. If you have any questions, please let me know in the comments. But if you don't have any questions, this is all I had for now, so I will see you next time.